Today, on Guess What I Found Out, the Northern Lights are gorgeous. They are also a warning system, and depending on what the sun is doing on any given day, they might be the last pretty thing you see before your power goes out for 6 months. Let's start with the pretty part. An aurora happens when charged particles streaming off the sun, a constant outflow called solar wind, get funneled by Earth's magnetic field down toward the poles. When those particles collide with atmospheric gases, they dump energy into the molecules. Oxygen, hit at the right altitude, releases that energy as green light. Lower down, it goes red. Nitrogen produces pink and purple. The result is what looks like the atmosphere performing its own private light show, which it absolutely is, just with electromagnetic physics as the DJ. The reason auroras appear near the poles is structural. Earth's magnetic field lines converge at the poles and dip downward, which is essentially a funnel. Charged particles follow those lines down into the upper atmosphere, usually between 100 and 300 kilometers up. Under normal conditions, auroras stay in a band called the auroral zone, which hugs the polar regions. Alaska, northern Canada, Scandinavia, southern tip of New Zealand. The dedicated enthusiasts know the territory. But here's where it gets interesting. When the sun throws a tantrum, the sun periodically launches what are called coronal mass ejections, or CMEs. These are massive eruptions of magnetized plasma, sometimes billions of tons of it, expelled at speeds up to 3,000 kilometers per second. When one of those hits Earth's magnetosphere directly, it compresses the shield on the day side and stretches it on the night side. The magnetic field bends, the auroral zone expands. Auroras push south, sometimes as far as Florida, Texas, even the Caribbean. When people in Miami are seeing the northern lights, that is not a tourism opportunity. That is a heads up. If you want to be the person who actually understands what's happening the next time the sky turns green over somewhere it shouldn't, follow Guess What I Found Out. We cover this exact category of thing that sounds decorative until it isn't. The benchmark event is 1859, the Carrington Event. A CME hit Earth so hard that, telegraph wires across North America and Europe began sparking, shocking operators, and in some cases even catching fire. Some telegraphs kept transmitting after operator disconnected the power, running entirely on induced geomagnetic current. Auroras were visible in Cuba, if you can believe it. People in the northeastern United States woke up thinking it was morning because the sky was so bright at 1 a.m. A repeat of the Carrington event today would not be a curious historical footnote. It would take down power grids across multiple continents. Modern estimates put the potential recovery time in months to over a year, depending on the region. We do not have a year's worth of replacement transformers sitting in warehouses. Nobody ordered them because, nobody wanted to think about this. We've had smaller previews, you know. In 1989, a geomagnetic storm knocked out power across the entire province of Quebec. 6 million people, 9 hours in March. In 2024, a significant solar storm, dubbed the Mother's Day event, disrupted GPS systems precise enough for agricultural equipment across the Midwest. Farmers in the middle of planting season found their automated tractors running offset rows. Millions of dollars in losses from a solar event that most people didn't even know happened. Well, here's your moment, Curious George. Why not drop a comment with the most unexpected thing you'd lose access to if GPS satellites were disrupted for, say, a whole week? Sure, navigation is the obvious one, but dig a little deeper. The answers get weird fast. So, what are scientists actually doing about this? Well, among other things, they're launching rockets directly into auroras. Poker Flat Research Range, just outside Fairbanks, Alaska, is positioned almost perfectly under the auroral zone and gets up to 20 hours of winter darkness per night. Scientists there fire sounding rockets into active auroral events, reaching altitudes of around 300 kilometers, measuring particle flows, electromagnetic currents, and ionosphere density in real time. Launches require everything to align: no moon, clear skies, an active aurora overhead, and instruments that have sometimes been in preparation for 3 years. When conditions hit, they have a window of minutes. The data from these missions feeds into physics-based computer models used to predict space weather events, which is what gives power grid operators and satellite managers any advance warning at all. It's painstaking, slow, narrow window science, and honestly, it's one of the better arguments for why fundamental research matters, even when the application isn't immediately obvious. Humans have been watching auroras for a long time without fully understanding them. In 34 AD, Emperor Tiberius sent his fire brigades toward a red auroral glow over Austria, convinced a city was burning. Vikings read them as omens. Inuit traditions described them as the spirits of animals dancing across the sky. None of these explanations are wrong in the most important sense. They recognized something significant was happening. What we know now is that auroras are readable text. The colors, the shape, the latitude, the intensity, all of it reflects what the sun is doing and how hard Earth's magnetic field is working to manage it. The same physics that makes the sky ripple green over Iceland can, at sufficient scale, knock out the satellite that's telling your phone where you are, or more critically, the grid that's keeping a hospital running in January. The lights are beautiful. They are also a reminder that we live inside a magnetic bubble, maintained by a liquid iron core churning 3,000 kilometers below our feet, holding off a star that could strip our atmosphere given enough time and the wrong geometry. Worth paying attention to. Worth understanding. Worth at least knowing what color to worry about when the sky starts doing things it doesn't usually do. More of this kind of thing lives on Guess What I Found Out. Nature, physics, and the occasional reminder that the universe has opinions about infrastructure. Browse around. Something will catch you off guard.